The binomial expansion gets its name from the fact that bi meaning two means we've got two terms. So we've got A plus B, and the expansion just means what do we get when we expand that. So we've got two terms, we've got a power up here, and from FOIL you can work this out, and we'll get A squared plus 2AB plus B squared. We can continue on, and we ask ourselves a question: what happens if we get A plus B to the power of 5? Can we just write our answer down? So what I hope you'll be able to do by the end of this is to be able to actually write this down without having to multiply out a series of brackets and get a final answer and collect like terms. So one way of doing that is to be able to remember Pascal's triangle. So let's just look at that first. Now, Pascal's triangle gets its name from a brilliant French. He was not only a mathematician, Blaise Pascal, but he was also a physicist, and he was a philosopher. He was born in the early 1600s, and he made a lot of contributions, as I say, both to mathematics and physics. Pascal's triangle works a little bit like this, and it's easy to remember. It always starts with a 1 at the top, and then we've got it like an equilateral triangle going on here. We're going to have 1 and 1, so it always starts with 1 and ends with 1. So that's the second line. Next one is 1. Now we add those two together. 1 plus 1, we get 2. We end with 1. So we start the next line with 1, end with 1. And the way to get the next one is to add these two terms together. And we'll add those two terms together to get that one. So we go 1, 1 plus 2 is 3, 2 plus 1 is 3. And then we'll do the next line, and we're going to add those two together, those two together, and those two together. So when we add 3 and 1, we get 4, 3 and 3, we get 6, 3 and 1, 4, 1, 1, 4 and 1, 5, 4 and 6, 10, 4 and 6, 10, 4 and 1, 5. Always starts and finishes with 1, and so on. You can keep going further on. So we use this one here for these numbers here for the coefficients. The coefficients are the numbers that go before the terms. So we use this for A plus B to the power of 0. N raised to the power of 0 is 1. This one will be A plus B to the power of 1, which is just 1A plus 1B. This is A plus B to the power of 2. And you can see here we've got, if we look at the coefficients up here, we've got 1, 2, and 1. And here we've got 1, 2, and 1. This is A plus B to the power of 3, A plus B to the power of 4, and this will be A plus B to the power of 5, and so on, A plus B to the power of 6. So if we want to know what are the expansions of that, these are the coefficients. Now, first of all, you know that if we've got to the power of 2, we've got 1, 2, 3 terms. So the number of terms is always one more than the power. So because we've got to the power of 5, we're going to have 6 terms here. The coefficients are going to be 1. So we're going to look. We've got to the power of 5, so these are going to be our coefficients. So it'll be 1, 5, 10, 10, 5, and 1. So it'll be 1. Now, how do we start? We always start with a to the power of 5, so it'll be 1a to the 5th plus 5. Now the powers of a go down by 1, so it'll be a to the 4, and this, if you like, is like b to the power of 0. So we've got b to the 0, and the powers of b now increase by 1. So we go b to the 0, b to the 1. And if you look, when you add the powers of a to the powers of b, you get the power for the expansion. So 5 plus 0 is 5, 4 plus 1 is 5, always pluses in here. And then this will be 10a. Now the powers of a are going down, so we've gone 5, 4, a to the power of 3. Powers of b are going up by 1, b to the power of 2, plus 10. These are going down, and the powers of b are going up. Once again, do a check. 3 plus 2 is 5, plus 5. Powers of a are going down to the 1, b to the power of 4, plus a to the power of 0 here, so, a to the power of 1 here, so this will be a to the power of 0, and the b's go up, so b to the power of 5. Now we know that anything raised to the power of 0 is 1, so, and we don't write 1 at the 1, so that'll be a to the 5 plus 5a to the 4b. We don't write b to the power of 1, we just write b, plus 10a to the power of 3, b to the power of 2, plus 10a to the 2, b to the 3, plus 5. Now we're looking at this term here now. A to the power of 1 is just a, b to the power of 4, plus, we don't write the 1, a to the power of 0 is 1, so 1 times 1 is just 1, b to the 5, or we just write b to the power of 5. So the important little checks as we go are that the powers of a and b must add up to be the power of the original binomial. And that will be the expansion. Now, we could have done a plus b, 5 lots of brackets, and then multiply the first 2 brackets, multiply the next 2 brackets, then multiply those together, then multiply by a plus b again. This certainly is a much quicker way to be able to do it. Now, there's no reason now why I can't do a plus b to the power of 6. We'd have to do another line here. And that will get you through the binomial expansion. Let's just do an example here now. So if we had 5x minus 2y to the power of 4, now I would write it as a plus b, so this is, if you like, my a, this is like my b, but we should write with a plus, so we'll go 5x, so that's my a, plus negative 2y, and that's all raised to the power of 4. So this is my a, and this is my b. Okay, now we've got to the power of 4, so we're going to use the 4th line of Pascal's triangle, so you need to be able to remember how to get Pascal's triangle. And my coefficients are 1, 4, 6, 4, and 1. So they are my coefficients of the terms. Because it's the power of 4, we would expect 5 terms, first term, second term, third, fourth, and fifth term, so that's correct. The a, we start with a to the power of 4 in this case, so my a will be 5x to the power of 4. We always put pluses here. Now we go the coefficient, and then a to the power, these a's now are going down by a term, by a factor, so we'll go down to the power of 3, so it'll be 5x to the power of 3, and my b's now which is negative 2y, to the power of 1. So once again, we add these two powers. 3 plus 1 is 4, so we should get that. Plus 6. The first will go down by 1 power, so it'll be 5x to the power of 2. And these will go up by 1 power, so it'll be minus 2y to the power of 2, plus 4. Once again, this is going up, down by a power, so it'll be 5x to the 1, negative 2y to the power of 3, plus 5x to the 0. We won't write to the 0, anything raised to the power of 0 is 1, and then this goes up by a power, so it'll be negative 2y to the power of 4. And then when we expand, we've got 1 times 5. Now 5 to the power of 4, not need the calculator. 5 to the power of 2 is 25, so it will be 25 squared, which is 625. X to the power of 4. Okay, now this plus here, when we expand this bracket, we've got negative 2y to the power of 1. So it's just negative 2 times 4 times 5 cubed, 125. That'll end up being negative 1,000. And then it'll be x to the power of 3. So we've got the numbers sorted. X to the power of 3, y to the 1. So just doing that again, we've got the 4. 5 to the power of 3 is 125. So 4 times 125 is 500. And that's times negative 2. So 500 times negative 2 is negative 1,000. Plus, or use your calculator. We've got 5 squared 25 times, now this negative 2, when we square, it's going to be a positive 4. And so this term will certainly be a plus. So that'll be 4 times 25 is 100 times 6 is 600. And that'll be x squared and y squared. Just checking all the time as we're going. 3 plus 1 is 4. Powers adding together give you that power. 2 plus 2 is 4. When we raise negative 2 to the power of 3, we're going to get negative 8. So this whole term is going to be negative. And when we multiply out there, we get 160. X power of 1, y the power of 3. Once again, checking that 1 plus 3 is 4, which is good. And the last term is negative 2 to the power of 4. A negative raised to an even power will always give you a positive answer, so this will be just a plus. 2 to the power of 4 is 16, and that'll be y to the power of 4. And once again, 4 will have x to the 0. Anything raised to the power of 0 is 1. So 0 plus 4 will be equal to 4. So there's my binomial expansion of 5x minus 2y to the power of 4.